Okay, here are the notes for sections 3.5 and 3.6, and I'm going to do an example of a system of equations that has infinitely many solutions. Okay, for this example, we need to begin by distributing. So I'm going to come over here to the side and distribute my 3 through the parentheses. And that is a 2 and not a z. So it'll be minus 6. And then I have x minus y, and I need to distribute the negative through the parentheses. Now, I just can't add these two because my variables aren't lined up. I need to get my y's together and my x's together, so I'm going to begin by doing that. So for the first one, I'm going to subtract 3y on both sides, which will give me 4x minus 2y equals negative 6. And on the second equation, I'm just going to add x to both sides, so that gives me 2x minus y equals 3. Okay, so I'm going to multiply the bottom equation by 2. And when I do that, I get 4x minus 2y is equal to 6. Okay, now if I decide to subtract the second equation from the first equation, and I just noticed I made a mistake, this is a negative, which means this is a negative, which means this is a negative. I have the exact same equations. So what's going to happen is you cannot say that your answer is all real numbers, because that would say that for any value of x, any value of y would work. No, that's not the case. The equation that solves the system is the line itself. There are infinitely many solutions. So the answer here is not all real numbers. The answer here is the line is the solution. It is an infinite set. So any point on the line. So when you get to this point, you can actually just stop. And let's try this one. 5x plus 6y equals negative 2. Okay, so let's solve this system. It's really convenient when you can solve a system of equations and the variables are exact opposite of each other, the coefficients. So I think I'm going to go with the smaller numbers and eliminate the x's. And 5 and 3 both go into 15. That's my goal. So I am going to multiply this one by 3. And opposite signs are nice, so I'm going to multiply that by negative 5. And what this gives me is 15x plus 16y equals negative 6. And then for the other one, I'm going to have negative 15x minus 25y equals negative 15. So when I add these together, I am actually going to go 18 minus 25, which is going to give me a negative, and that gives me a negative 7. And this gives me a negative 21. Very convenient that negative 7 goes into there, so y is equal to 3. So a system of equations must be answered by a complete coordinate. All I have is y, so I need to find my x. And again, I am going to go into and use the smaller numbers, and I want to substitute my y is equal to 3 right here in the bottom. So I've got 3 times 3, nope, 3 times x, x is what I'm looking for, plus 5 times 3 equals 3. And 3x plus 15 equals 3. And 3x is equal to, whoops, negative 12. So x is equal to negative 4. And we have negative 4, 3 for my solution. And we check that by plugging it in. And that is it for this section.